In this chapter or section 5, we will talk about the liquidity structure of the firm, and that means the duration of financial contracts. What does that mean? It means that if a firm has a lot of short-term finance, then it has to pay back these loans or whatever it is. And that means a lot of liquidity is sucked out of its balance sheet. And that means that the firm may run into a liquidity problem. That means it may be unable to honor its liabilities. If it has a lot of long-term debt, then it's the other way around. Then it can wait for a long time until it has to repay the debt. And okay, then typically it will not run into such liquidity problems. And the question that we want to ask is, well, why do we have, what determines long-term debt versus short-term debt in the first place? Why don't all firms just choose as much long-term debt as possible? Right. If we want to ask that question, something I've already said is we have to enrich the model. That's what we typically have to do in all of these extensions. We have to add something to the original model. In our case, it has to be an additional date in time, period in time, because we need at least one initial date where the contract is written and the investment project is started. Then we need some intermediate date, which is the short-term date, and then we need a long-term date. Of course, we could have even more than that, 3, 4, 5, 6, 7 days dates. But the minimum that we need is 3 dates. And as we know, Jean Tirole always tries to keep everything as simple as possible. So we just have 3 dates. Okay, let's start and let's see what the model looks like. So we have a firm, everything as before, but now this firm has project size I. In the beginning, it will be a constant size I, so it's a fixed investment model. And later on, we will also talk about the variable investment model. So you see, it's combinations. In the chapter 3, we have seen fixed investment models and variable investment models. And now whatever we do, we can always do in the fixed investment version or in the variable investment version, whatever we prefer, or we can do both. So we start with the fixed investment version, and there is a liquidity shock in between. So we discuss 2 examples, and we will talk more about that, what exactly that means. So 2 different examples. One is called the cash poor firm. Those are firms that have no or little cash in the short run, and that means that if there is something happening in the short run, typically they are unable to repay part of the debt in the short run anyway, but they might need additional liquidity assistance from outsiders, from the investors. So they might cry for help. They might say, "Look here, dear investors, I have I have a problem. I need more cash, otherwise I cannot continue my project." So that would be a typical cash poor firm. A cash rich firm, that's a firm that has a lot of intermediate cash, a lot of cash in the short run. So it could even start to repay part of its debt in the short run. Might even be forced to repay part of its debt in the short run. And the question is then, why should it be optimal to implement a force to repay part of the debt if that's unnecessary? If that's, I mean, what's the reason for that? Okay. What happens if I do have liquidity needs? So if I'm in the first example, if I'm a cash poor firm, then there are 2 different things that I can do. For example, I could try to just have a liquidity buffer in the balance sheet so that if there is a liquidity problem, if there's a shock, then I have my own liquidity in order to pay for the shock, to repair my machines or whatever it could be. Or I could also have a line of credit. So that means that if there is a liquidity shock, I can go to the bank and say, "Look here, I have the credit line. Please give me more loans." Or there's a third thing that's not on the slide here. That's the what we could call wait and see strategy. I'm going to write it up. So I'm going to have a little nice triangle. wait and see. That means I just wait until there is a potential shock, and then if there is a shock, I go to the markets and say, look, I have a shock, who would be willing to give me more finance? Okay, that's just getting new equity or getting a short-term loan from a bank or something like that. So let's go right into the model because we can always talk more about the interpretation in face to face. I think that probably makes a little bit more sense. So how does the model look like? Basic setup is the same as before, but now, so it's like in 3.2, but now we have this additional intermediate date at which there is some potential income or some reinvestment need. Okay, so as before, at date zero, the entrepreneur has wealth A and the investment need is I minus A. So we always try to keep as much as possible same as before. Okay, at date one, there is the investment yield, and we assume that that's deterministic. So I already get cash out of the project, and that's called lowercase r. And it's also verifiable. So no moral hazard problem here. But then there's this shock. Continuation of the project requires an additional payment of rho, and this rho is stochastic. It follows a distribution function f of rho, and so rho is ex ante unknown, and the support of rho, so the set of potential values, is between 0 and infinity. So we assume that lots of different shocks are possible. Realization of rho is learned at date one, and so we assume that R is deterministic and rho is stochastic, but it could also be the other way around. It's just important that one of the two is stochastic, and that what we care about most is the difference between the two. So it's the net the net intermediate need for cash that the firm has. So if some money comes out of the firm, and then there's also a need for repairing the machine, then this cash can be used to repair the machine, at least partially. So it's mostly the difference between R and rho that matters, and not so much the values itself. Okay. So how can we think about this rho? Well, as I already said, I like to have it as colorful as possible. So I like to think about it as just a firm that buys a machine from the initial I, so the machine costs I, and then at this intermediate date, something can happen to the machine. For example, it could break down, and then I have to pay something in order to repair the machine. And if the machine is not repaired, then it's useless. And we also assume that the liquidation value is 0, so we cannot even get money back for the machine. That's an extreme assumption, but let's do it as simple as possible. So this is, of course, a very easy interpretation. One could also think about lots of different things. Like, for example, one could assume that we want to start a restaurant, and this initial I is used in order to buy a kitchen, to have some marketing campaign so that we get the restaurant going. Okay. And then there's this intermediate date. What could happen there? Well, it could, for example, be that already after some short period, the first customers arrive, or it could be that it takes some more time until the customers come. Okay. So therefore, we don't know exactly how large the cash flow in a date one is. So that would be another interpretation. Or it could be a medical firm that tries to produce a medicine, a drug, and let's assume that it knows that it's just going to take time until the drug is developed, but potentially at this intermediate date, it realizes, oh, it's a little bit more difficult than we thought. We need some more money for a little bit more research or for another test series. Otherwise, it's not going to run. And this would be another interpretation. So you see lots of interpretations. The only thing that's important is that at date one, there is some uncertainty about either short-term return, or in our model, we concentrate on some additional finance that I need. Okay. We still also have the moral hazard problem. That's very important. And you can think about that later on, why we need the moral hazard problem, why we just don't have a model without moral hazard and just a multi-period model. And the answer is that in a multi-period model without the moral hazard problem, there the long-term versus short-term finance does not matter. Like often, if you ask the question, what's better, having a short-term financing contract that revolves, so that would be the alternative to long-term finance, having a series of short-term financial contracts that always has to be repaid after one period, but then the entrepreneur just gets a new loan and uses the money from the new loan in order to repay the initial contract, and that would be exactly equivalent. Okay, so therefore we need this moral hazard problem, and that's exactly the same as before. And everything else is also the same as before. Everything is risk neutral. Everybody's risk neutral. There's still limited liability. Return rate is equal to 0 from the investors. Everything as before. So we are then done with step number 1, the definition of the new model, and we turn to step 2. After 1 comes 2, and that's the optimal contract. Looking at the optimal contract from a mathematical perspective, and the third step is then the interpretation of this optimal contract. Well, whenever we extend the original model, typically the contracting space becomes more interesting. And that's also the case here. So we now have 2 contracting variables, one variable, at least 2, one variable that says what should be the optimal repayment in the long run, and another one that says or how should the repayment in the long run be distributed, and one that says how should the payments in the short run, in the intermediate period, be shared between the 2 parties, and then one that says, well, if there is the shock row, should the project be continued at all? Because we could also say, if the shock is large, we could, let's say we have initially invested $1 million into the machine, and now we see it's a little bit like the airport in Berlin, that we see that the repairing or the initial investment, intermediate investment, is maybe 7 times as expensive as the initial investment, and that implies that possibly we at some point we should say, no, it's not worth it. Let's stop here. Okay, we will see that the 2 variables, how much should be repaid in the short run, and whether we should continue or stop the project, they are heavily interlinked. Okay, so therefore let's first concentrate on this variable that we call rho star, and that's rho star, that's the cutoff value. Whenever the reinvestment need is larger than rho star, then we should not reinvest. We should stop the project and abandon the project. So that means also that the original investment of I is also lost. But if the repair cost smaller than this rho star, then we should go on repair the machine. Okay, so there's one critical value that gives us exactly case differentiation whether the machine should be repaired or not. If the machine should always be repaired, that's one border solution, then we should set rho star to infinity. Probably doesn't make sense because it's a lot of money, infinite amount of money to repair the machine. And if it should never be repaired, whenever something happens, then we can set rho star to 0. So all these cases are already contained in the choice of rho star. Right. Same argument as in the chapter before, because there's the perfect competition between the investors. That means that there's 0 surplus for the investors. So as a consequence, the borrower's utility is equal to the NPV. So we now just have to write up what's the NPV of the project depending on whether we continue the project or not. Okay, so there's already a lot of abstraction in this, that we say, okay, however the cash is divided between uh, investors and entrepreneur at the intermediate and the final date, uh, what the what matters for the entrepreneur is mainly the NPV of the project, and the NPV does not depend on how the proceeds are shared. That just depends on the rho star. So let's try to calculate the optimal rho star.